Okay, we're going to start our unit on quadratics, and a lot of this will be review of grade 10, so it should be something you can handle at home. There's lots of examples in your textbook to read, so right off the bat, for more examples, see textbook page 163 to 167. There's tons of examples in there, so if you're having trouble with any of the video examples I'm doing, just check that out. All right, so today we're going to be talking about some radical arithmetic and simplifying radicals. So what's a radical? Well, let's start right here. You know what a radical is. You've actually worked with usually called it a square root, but that's only when it's a 2. So a square root. But for the case of everything, we can call these square roots, but we're also going to call them radicals. So that's what this symbol is. It's called a radical symbol. What's a radicand? The radicand is just the number underneath a radical. Now, let's talk about different kinds of radicals. An entire radical is a radical that has a coefficient of 1. So in other words, the number out front of this radical would be a 1, and whatever's out front is multiplying it. Whereas a mixed radical is a radical that has a coefficient other than 1. So in this case, this is 3 times the square root of 26. And finally, we have like radicals, our final definition. Those are radicals that have the same radicand, so the number underneath the radical symbol or the square root symbol. So in this case, we'd call these like radicals because they're both square root of 2. All right, so let's do some simplifying. We're going to do 3 lessons on the topic of radicals, and the first one we're just going to talk about simplifying. Now, everybody knows the square root of 25 is 5, but what I want you to think about is, why is it? Because what does that mean? 5 times 5, right? It's a pair of 5s underneath the square root symbol or the radical symbol. So 5 times 5, square root of 5 times 5 is 5. Same with 16. The square root of 16 is the square root of 4 times 4. It's a pair of 4s, which gives us a 4. So what about 12? 12 isn't a perfect square, but I could break 12 into, let's say, 4 times 3. And I could break that 4 down into 2 times 2 times 3. So in other words, there's a pair of 2's here. So forget the 3 for a minute. What's the square root of 2 times 2? It's 2, with this 3 left underneath the square root symbol. So that's how we simplify a radical. We want to find pairs of numbers. Now, perfect squares, we're so used to it, we probably didn't think about doing it this way in the past, but that's how we want to do some of these, okay? So let's move down the page and we're going to check out a couple here. And right off the bat, we got our first radical property, which is when you are multiplying 2 numbers underneath a radical symbol, you can break it up as 2 separate radicals. So just for example, if I had the square root of 2 times 3, I could write that as square root of 2 times square root of 3. All right, so let's put that into action. So the square root of 44. If you put that in the calculator, it's going to get a decimal number. So what we want to do is we want to write that as the square root of prime factors. So what does that mean? We want to prime factorize 44. So what do I mean by that? Well, let's take 44, and a lot of you have probably done some prime factoring, and let's divide it by only prime numbers. So let's say, what's 44 divided by 2? 4 divided by 2 is 22. All right, I can divide that by 2 again, 2, which gives me 11. And 11 is a prime number. So that means the square root of 44 can be broken down into 2 times 2, which is 4, times 11, which is 44. Now, to simplify this, we're looking for pairs of numbers. Here's a pair, 2 times 2. 2 times 2 is 4. The square root of 4 is 2. So anytime we have a pair, what we do is we take the square root of that, which is 2, and we leave the other numbers underneath. All right, so we've simplified that. Let's do another one here, 72. All right, so 72. Why don't we try to prime factorize that? Or we can, we can break it down to some different numbers. So let's go, well, what's 72 divided by 2? All right, 72 divided by 2 is 36. Now, right there, that's a perfect square. So I'm not going to break that down anymore. So let me show you what I mean. I can write it like this, 2 times 36. Now, isn't 36 6 times 6? So we've got a pair of numbers. Anytime we have a pair, we can pull that pair out by saying, well, the square root of 6 times 6 is the square root of 36, which is 6. What's left underneath is the 2, and it's been simplified. All right, let's do 75. Well, what can we break 75 down into? I can definitely divide it by 5. So I'm going to go over here to the side and go, all right, what's 75 divided by 5? 75 divided by 5 is 15. And what can I break 15 down to? I can divide that by 5 again. And 15 divided by 5 is 3. So therefore, sorry, I don't have a lot of room here. I can write 75 as 5 times 5 times 3. So we have a pair of 5s. So to simplify it, we're going to say, all right, what's the square root of 5 times 5? That's the square root of 25. It's 5. So we pull out that pair and we just make it into a 5. And what's left underneath is the 3. And then we multiply the numbers out front. 2 times 5 is 10, 10 root 3. All right, let's rationalize one more number here. Or not rationalize, simplify is the word I'm looking for. We'll talk about rationalizing a little later. All right, 252, that's a big number. So let's go over here and say, well, what can I divide that by? Again, we're looking at prime numbers. So think about what are your prime numbers? 2, 3, 5, 7, 11, so on and so forth, right? So start with the easiest number, which is 2. If it's even, it's divisible by 2. So 252 divided by 2 is going to be 126. I can still divide that by 2. Divide that by 2, and I get 63. Well, what's a prime number I can divide 63 by? How about 3? All right, 63 divided by 3 is 21. Hey, I can divide that by 3 again. 21 divided by 3 is 7, and 7 is a prime number. So we just prime factored 252 into 2 times 2 times 3 times 3 times 7. Now in this case, you have a pair of 2's, so the square root of 2 times 2, which is the square root of 4, is 2, and the square root of 3 times 3, which is the square root of 9, is 3. So what you end up doing is, you put a 2 out front, because you've taken the square root of 2 times 2, put a 3 out front, because you've taken the square root of 3, and the 7, we're going to leave underneath. 2 times 2 is 6, root 7. All right, so that's our first skill. We want to be able to simplify radicals. So we do that by factoring the numbers underneath and looking for pairs. As soon as we see a pair, we basically take the square root of that pair and we put the number out front, which is basically you get rid of the pair underneath and you just write one of that number out front. All right, let's move down the page and check out a couple more examples. Okay, so let's multiply some radicals now. Now, using the radical property we showed above, that says, hey, if I have something times something, oops. Okay, using the property above, I'll just paste it here, that's the property right above. It says that if you are multiplying, you can break it up into 2 factors. But I can also multiply these together and rewrite it like that. So in this case, 3 root 15, I can put all of that underneath one radical and multiply. Now, it doesn't work with addition or subtraction. It only works with multiplication, division. All right, so now 3 times 15. Instead of doing 3 times 15, why don't we break 15 down into prime numbers? 15 can be broken down into 3 times 5. All right, we've got a pair of 3's. So what we're going to do is take the square root of 3 times 3. The square root of 3 times 3 is 9. Or sorry, the square root of 9 is 3. So we write the 3 out front, and what's left is the 5 underneath. All right, let me just clean up some of this stuff. We'll get some of this stuff out of the way, and we'll do a few more examples. Okay, the next example here, we can multiply the numbers out front like normal, and we can multiply the radicands, which are the numbers under the radical. So we can go 3 times 2 and multiply that by 2 times 7 underneath the radical. 3 times 2 is obviously 6. Now, underneath the radical, we have no pairs. So let's just multiply them, and 2 times 7 is 14. Done. That's as simple as that one can get. All right, let's look at the next one here. All right, in the next case, I'll just bring it down so I have a little more room here. We can multiply the numbers out front. We got a 5 and a 2, so those are the coefficients. Coefficient basically meaning the number out front. So 5 times 2 is 10. I'm just going to multiply them right away. And underneath, we can multiply the radicands. 6 times 10 times 15. Now, we can prime factorize each of these numbers. So let's break them down to prime factors, and then let's look for pairs. So 6 can be broken down to 2 times 3. 10 can be broken down to 2 times 5. And 15 can be broken down into 3 times 5. So it looks like we actually have 3 pairs of numbers because we have a pair of 2's, we have a pair of 3's, and we have a pair of 5's. So in other words, everything can come out of the square root. Now, what we do is, remember, we get rid of the pair, like 2 times 2 is 4, and the square root of 4 is 2, so we put a 2 out front. 3 times 3 is 9. Square root of 9 is 3, so we put a 3 out front. And then 5 times 5 is 25, square root of 25 is 5. So again, basically what it looks like we're doing is if we find a pair, we get rid of the pair, and we just write one of the number from the pair out front. In this case, there's nothing left under the radical, so we can get rid of it and just multiply what's left. 10 times 2 is 20. 20 times 3 is 60, and 60 times 5 is 300. Now, obviously, your calculator could do a lot of this, but this is a skill you really got to try yourself. Don't just completely rely on your calculator. Of course, you can check your work over, but use your calculator. Sorry, try to do it without doing everything on your calculator. All right, next one. Let's multiply what's out front. Negative 3 times 5. We can multiply the coefficients. Negative 3 times 5 is negative 15. And we can multiply the numbers underneath. 2 times 6. Now, the 2 is already a prime number, but that 6 I can break down into 2 times 3. So, look, we've got a pair of 2's. So, 2 times 2 is 4. The square root of 4 is 2. So, I'm going to bring a 2 out front, multiply it by the 15, and the 3 doesn't have a pair, so just leave it underneath. Negative 15 times 2 is negative 30, square root 3. Okay, so that's how we multiply and simplify radicals. Okay, this is the end of lesson 1. So when you get to your assignment sheet, any of the lesson 1 questions will be dealing with these topics. And again, there's some textbook examples you can look at to help too.